everybody is trying to solve problems with data, but what does it take to actually do that? And so this presentation is going to cover some of the key roles for helping to solve data problems. How do we go about reasoning about these kinds of roles? How do we go hire for them? And what happens when we only have 2 or 3 individuals on a team? What happens when there's still responsibilities to be shared across an organization? How does that work without it being super confusing? So, I mean, the main takeaway here is that in order to solve problems with data, it takes more than just one data engineer. And we know this because there's a huge space and potential opportunity for data solutions. When we think about all the organizations that want to use data to solve interesting problems, it's a lot more than the actual talent that we have out there. So in the United States, we have over close to 4 million software developers. But if we look at the actual pool of people who have AI backgrounds and capabilities and just knowledge of machine learning and artificial intelligence, we see that it's a very small pool of people. And when we think about people who are actually contributing to AI systems and driving what we know as state of the art, that's an even smaller subset. So of the millions of developers out there in the world, there are only 5,000 individuals actively publishing research around this topic. And so if we actually want to continue to scale out data solutions in this industry, we have to extend how we talk about data to be more inclusive. And so that's the reasoning behind this presentation, right? There's so many different words associated with a data team. There's the data engineer, your analysts, ETL developers, DevOps, ML ops, pipelines, big data, data scientists. It can be really confusing. And so if we just want to pare down some of the essentials about machine learning teams and full stack data solution teams, I think we can look at 5 roles to start with. And I want to break down all of these roles. And if you have any questions, feel free to ask. I'm going to pull up chat just to make sure. But essentially, let's talk about some of these roles and how we can actually build teams that are building solutions that give us more insights and access to the data that we're collecting, right? Because at the end of the day, it doesn't matter that we just collect data if we're not using it, if it's not accessible, and if it's not integrated into our solutions. And so if we're thinking about it from that perspective, we need quite a few job responsibilities that are handled in the team. Oops. So let's start with the DevOps engineer. That's a title that people are pretty comfortable with when it comes to DevOps. We really want to think about it as the main power line in a house, right? If we don't have someone to turn on the lights, then we technically don't even have an application that will be available to any users. And so in a machine learning team, in a data science team, in any of your data teams, really your DevOps engineer is there to ensure that the production systems are up and running. And so they'll be working in AWS, provisioning infrastructure, making sure that things are working well. You're monitoring your actual systems working. If there's an incident, right? Say, for example, for whatever reason, your data center or your AWS infrastructure goes down, they have some contingency plan to ensure that things are still working in some sense of the word. So that's a common team role that fits into our machine learning teams, and it fits into a lot of our other teams, right? Any of our software teams, the DevOps engineer is very essential. Sometimes they're called SREs. The role changes, but essentially there's someone there ensuring that our production systems are working. Second role that I want to break down is the role of the data engineer. So the data engineer has actually been in the industry for quite longer. This is a role that we've actually known about or had data engineers on our teams for the past 30 years or so. And these folks deal with collecting data, retrieving it, transforming it, housing it in our databases through, with SQL and then setting up SQL queries, right, to be able to retrieve that data and use it in effective ways. It's extended further now because of big data, where people are managing whole clusters of data, working with big data, working with data warehousing. Some people are also arguing like data warehousing is over now and we've got to move to data lakes and even things called lake house architectures. So there's quite a bit around the space that's evolved since then, but typically the data engineer will really be thinking about, how do I aggregate data? How do I make it available to folks? You know, how can we monitor if there are any issues with being able to pull in data, or what happens if there's a schema change? So they're really thinking about serving this data on a platter, right, to be able to be consumed by other teams. Sometimes you'll have a data engineer that isn't in a data team, right? They're in a typical software engineering team, and they're doing this work. So it's, you know, these roles exist outside of a traditional data science team. Then you have the machine learning engineer. Like Moses showed us, that was the pipeline for being able to train and deploy a model that we were working on, right, with Forte 2.0. It's the same situation here. Your ML engineer is really thinking about, well, how can I build pipelines to help make this process repeatable? And oftentimes when we're working with ML applications, you know, we're training models multiple times, you know, to ensure that the performance is working well. You know, we're getting good accuracy on our results. Sometimes we're just tuning aspects, right? We want to test out, well, you know, this model that we deployed didn't do too well, or maybe there's data drift and we need to redo this process. And sometimes traditionally, when you've asked data teams, how do we go back and train this, or how do we go back and like fix this model up and then deploy it, that's been a real big struggle. There's no record of it. It's not sustainable. There are people who just have Juniper notebooks or their own code somewhere out there, and they have to dig it back up and pull it back up to change it and then deploy it again. And it's this real big mess. And so ML engineers here are really helping organize that work so that it is this repeatable process. And, you know, after we've trained a model and deployed it, it's going to be used billions of times before it has to get retrained again, you know, and retuned. So just think of it from the perspective of, is like, if you have multiple models and multiple opportunities to train and get this to be very performant, the ML engineer is going to be working with the data engineer to make sure that, you know, the models can receive the data, can train, and then they're going to be working also with our next role, the ML researcher, to figure out what is the best way to improve the performance and productionalize the models so that people are happy, right? Customers can use them, users can get insights into our data. And so the ML engineer or the ML researcher here, they're typically a lot more invested into the machine learning space. So these are people with PhDs who are actively contributing to research in the space. They have good ideas about the theoreticals around designing prediction models, around how to measure performance given a particular data set. So say, for example, you collect some data and it's heavily imbalanced for whatever reason. You know, you can even take gender as a demographic or a type of data set. You know, we collect a lot of information and only 10% of it represents people who identify as women, right? That can be really challenging if you're gonna build these systems and say, well, it works well for everybody, when in reality, you didn't look at the performance or the accuracy based on the fact that your data was just imbalanced. So there are certain considerations that the ML researcher will have to make and think about in terms of the use case to be able to design better prediction models that are fair, right? That don't introduce bias. We've heard so many stories about different ML models or AI applications that are biased, right? That don't serve our communities. Instead, they cause problems. So this is the work that ML researchers typically do. And on the far right here, you'll see like they'll work in Juniper notebooks, PyTorch, TensorFlow, which are all machine learning libraries that are based in Python. So they'll be doing the coding and the communication around that. And then our last and final role here that I want to cover is the data scientist role. And data science, if you think about it, is this blanket term that typically describes a lot of all of these things that you'll be doing, right? What we're going to be doing with data warehousing, what we're going to be doing with data collection, right? What are we going to do with actually using that data? So a typical data scientist, that role can actually encompass quite a bit of things. Sometimes your data scientist will be an ML researcher, but also your ML engineer. So that's just something to note there, is that people are still trying to figure out exactly like where do they fall into these buckets, and what are they going to be doing when there's a job description and it says data engineer, but then they join and it's not really data engineering. What happens then, right? And so we need to be realistic about what these roles are doing and what happens when you start to bleed into other job functions when you have a particular role, because that can happen. And I really like this next diagram because it explains like what happens when you don't have, for example, a data scientist or a DevOps engineer who's going to be taking over some of those key job functions, right? So on your X and Y axis, you have the skills or the level of expertise needed in a particular field. So with your engineering roles, you typically need to have quite a bit more skills around software engineering. So, how well do you work with different software engineering type tools, practices, things that will help us productionalize this application, versus in machine learning where it's heavily domain based, right? Do you know the current practices? Do you know the architectures, the NLP, big data, all of the different use cases, and how can you work with that? And then this third dimension is around technical writing and communication, because that's also important in a team, right? We need to be able to talk about what we're exactly doing, right? And in some cases, it's more important in some roles than in others. And you see that with the data scientist role, is typically that's the first type of hire that teams or organizations that are building data teams will hire, because they need someone to be able to start talking to stakeholders about machine learning. And even if they may not be able to speak on the very cutting edge or crazy use cases, they are able to explain this across an organization and slowly begin to articulate it down to other parts of these job functions. And so typically this is how you handle people moving across or trying new things, right, in the team, and trying and thinking like, well, maybe I'm interested in machine learning. What's the next steps for me as a data engineer, for example? Well, a really great opportunity for a data engineer to get more machine learning expertise or hands-on expertise is to begin in a machine learning engineering role, where they're going to start deploying these models. They're going to be working more closely with the data scientists and the ML researcher to be able to figure out, well, what was the reasoning behind the design, and so on and so forth. And your ML engineers, they may decide to move towards more software engineering expertise. Maybe they want to learn more about DevOps and what it means to continuously deliver value, or otherwise, they may start off in this very heavy, this very strong background in software engineering, and now they want to move towards machine learning researcher or data scientist role, where they're more integrated into the communications and the conversations around machine learning. So this is just like a highlight and a industry as a whole kind of snapshot of how roles are organized, right? Again, you can have outliers in this graph. You could be, very software, you can come from a heavy software engineering background and still be a machine learning researcher, for example. You're a unicorn. You're welcome. So that's just something to know, is like you can fall anywhere in the spectrum, but it is helpful to be able to map particular roles and particular expectations to these kinds of roles. All right, so let's talk about each of these roles a little bit more in detail. I kind of went over all of these things, but in your DevOps role, or DevOps engineer who is in your ML teams, they'll typically come from a software engineering experience. They'll know about how to build standard CI/CD pipelines, everything to get you from code commit to production, right? And they're not just bringing over like that pipeline, or they're not just like working in a silo. They're bringing all of their expertise about agile, about working in DevOps manner and that DevOps culture, right? They're bringing that into the team and really helping other folks or individuals in the team who maybe they don't have a software engineering background, or maybe they're not used to working in a Scrum or Agile way. They're helping to bridge that gap. And so it's a lot more than what we think it is, or what these slides may tell you it is. And then your data engineer, they can typically have experience in software engineering as well. They may have already worked on software engineering teams as like the data engineer. So it's not too uncommon to have a data engineer who wants to be a part of a machine learning team and actively learn more about machine learning concepts, especially as a lot of organizations and companies just want more intelligence, right? And we've had a lot, and as a society as a whole has found a lot of really great discoveries through deep learning and machine learning. And I'm actually going to cover more of those amazing discoveries next week in a session that's like 0 to hero machine learning. So we're going to be covering all these things eventually. But I do want to talk about these roles because I think it's super cool to think like we have so many people with diverse backgrounds and how that can actually come all together to build these amazing teams, right? And so machine learning engineers, they can have a variety of backgrounds. You can come from a software engineering background with quite a bit of machine learning experience. Maybe you did a data science degree, master's degree, bachelor's specialization, whatever it happens to be. Some people like will go back to school and learn more about machine learning, and this is where they'll end up falling into the machine learning or data science space, right? And it's great because it's sort of the practical standpoint of like, okay, we're not just developing models or doing research for the sake of doing research, we're actually putting these out into production and making them useful. Money cakes, revenue, all of the fun stuff, right? So that's the machine learning engineer. And then you have your masterminds, your big brain energy. It doesn't really matter what background you have, but typically the ML engineer will have a master's or a PhD in data science, machine learning, CS, statistics. Some people come from a behavioral background, and then they end up doing quite a bit of work in the machine learning space, just because there's a lot of similarities between how we model our machine learning models and how like the brain and human functions work. So there is a relationship there, and it's helpful to have people across different domains contributing to the design and the architecture and like cutting edge solutions in this space, especially as we get to explore more opportunities. And your ML engineer and your data engineer have all these things covered, right? We have like this healthy pipeline or this healthy infrastructure around consuming data and using it, and we understand it, and there's someone who's cleaning it. These are all really important things, right? If we don't have good data, we don't have good machine learning models. You feed in crap, you get crap back out, right? So all these other roles I think are really, really important for ML researchers to be able to do what they're doing in the space now. And there are other organizations in the space related to machine learning. If you've heard of OpenAI, Elon Musk, I think, is on the board. He either started it, or he's on the board. I don't know if he started it. He was probably one of the folks who initially funded a lot of it, but OpenAI is one nonprofit organization that's helping build open source AI solutions. If you've heard of GPT-2, GPT-3, that's a natural language processing model, which will help build intelligent the virtual assistants, for example, because they can basically build presentations like this and generate text in a smart way. There we go. That was very nuanced of me to describe that. But those are just some examples, right, of ML researchers contributing back to the community, giving people great ideas for how to use these in a practical sense. And then again, your data scientist has a background in machine learning as well. Okay, I went over quite a bit of roles. I went over 5 different roles and how they help build a complete machine learning team. And by complete, I mean teams that are integrating and building data models and solutions that we can actually use from the data that we're collecting. Haha, funny. Yes, don't you love these slides that have been adapted? All right, let's talk about team structures. So machine learning team structures. Always fun to talk about some of these newer aspects of building teams that haven't traditionally been built in industry, because there tends to not be a very good consensus across the industry as a whole. And when do we name a role a data engineer versus a ML engineer? And what happens if the person who's hiring or creating these job descriptions don't come from a machine learning or a data background? Yeah, then you start to get quite a bit of bias, quite a bit of just, well, we'll call them white lies, right? And so there's no real consensus about how to structure a complete machine learning team. The typical way that we want to structure them is to have a good mix of software engineering skills and machine learning skills on the team, just because it's that good balance. A lot of machine learning folks come from a heavy academic background, but those skills aren't necessarily the same skills that you need to be able to get something working in production, right? Or it's not necessarily the same skills that will help you have great collaborations between multiple people working on a single code base, right? Hence why we use version control and GitHub and pull requests, right? Those aren't the same mix of skills traditionally. And so some people will definitely say that you need that on a team. Otherwise, you'll never get past the traditional or the initial phases of developing a model. So that's one consensus that we can make, I think, across machine learning team structures. One other kind of area of challenge, I think, is that there's just different views on the role of researchers and engineers as a whole. Some people think that machine learning researchers shouldn't be integrated in our teams, shouldn't be a part of our data teams, and they should kind of be in their own silo where they work on their own and then just throw the model over the fence, because it's hard. It's hard. You have your software engineering teams that are moving in a particular cadence, particular way, right? And then you have these ML researchers who are still experimenting, are spending time thinking about these these models and design. They're reading papers, they're trying to figure out all these use cases, and they may not know what is the best performance change that they can make. And we'll talk about that a little bit later. Other people think the more ML expertise you have, the better your teams are going to be off, right? Because if you are going to be building these cutting edge solutions with data, if you want, because all this is relatively new, right? A lot of what had to happen in order to make deep learning and machine learning work well took years. And in some cases, it wasn't until fairly recently, within the past 10 years, that deep learning even became viable. Because for the longest time, it wasn't. And people couldn't figure out why. And so a lot of people, so there were people who were skeptics about picking particular design choices or using particular types of machine algorithms and ways of designing models. We also have different views on data engineering. Some people say that it should be a separate team. You should have a separate team that manages data warehousing. Some people will say that a data engineer should also be working on cleaning data and labeling it, because at the end of the day, our machine learning models will either use labeled data, use all sorts of data, right? Labeled data, non-labeled data, structured, non-structured, right? And so sometimes some people will say we need a dedicated team for that as well. So it continues to grow. And I think, like, depending on your organization and how your industry is set up and exactly how you want to manage the data, this can look different as well. At the end of the day, though, when we think about designing products and solutions in an ML team, it can be kind of challenging in terms of, for a number of reasons. For one thing, this is an accuracy or performance graph of a model, by the way. You can see that when we first started, we first deployed the model, the accuracy was about 35%. So that's worse than guessing. I could flip a coin and get a better accuracy than the model, right? And then, a couple of days later, we get up to 70%, right? But then we keep tuning it and trying things out to maybe get 90 or 80% confidence. You're never going to get 100% confidence unless, again, you're a unicorn. But we tend to strive for 80%, 70%, 90%. But sometimes the reality of it is when we make these changes, we'll go back down in accuracy. We'll hit back down to the 50%. And it'll take more deployments and more research to figure out why this is the case and how can we actually make it better. And it's not always indicative of the number of people in our teams and how many people we have on our teams helping us. And so progress is really non-linear in this sense. And production ML is still somewhere between research and engineering. It is that back and forth that we have to do. It's a little bit of that dance. And it's also a struggle because there are different values and norms and ways of working across ML teams that we designed. I mean, I showed you all some of the background that some of these roles typically have and what are the expectations around them, right? And because of that, there's different values and different ways of working and priorities that people have across that team. And another challenge I think that makes it difficult is that oftentimes leadership doesn't have as much experience with data teams, managing data teams and managing ML teams than they would a traditional software engineering team. And we can't go about it with the perspective of like, oh, it has to be this way because we've seen it done in this setting like this before, because this is a whole new setting, right? With whole new problems and challenges in and of itself. And so these are some of the reasons why building and managing ML teams can be a challenge. So I'm at the end of my presentation, but I wanted to talk about like, how do you actually go about like figuring out if someone is a good fit for the team, and like, what are some questions that you can ask or begin to ask around or understand around machine learning? And there's a couple of different things that we can ask them, right? We can go back to like, why are we trying to solve these problems? We can also do deep dives on machine learning theory and debugging, like why performance matters, why we want to design certain systems the way that we do, what are certain conventions that we should stick to, what are some conventions that we shouldn't stick to because we're moving away from them as an industry. I think there's also a lot of, finally, a lot that we can do around building great teams and studying team dynamics. So there's actually a lot of research on building agile and software development teams already. If you've heard of some of the work that Google was doing, they have studies on this as well. There are things called tilt assessments that will help you kind of understand who you are as a person on a team, why you may argue with other people on other teams. So there's a lot of trainings as well that will, and studies too, that will go over like, how do you actually mesh well with a team? And a lot of it goes back down to what are people's strengths and what are people's values. So if we can begin to understand that, then we can begin to build really complete and amazing machine learning teams. So that's actually all that I had for this session. I called it the lovable guide because I did want to leave everybody with this feeling that like, yes, there are challenges, but we can begin to solve them just by going over, beginning to understand like what is the landscape of this and how can we bridge that gap by having these meaningful, awesome conversations. So thanks all for listening.
Thank you so much, Tiffany. I had a couple questions in regards to like the data side of things. The first one is like I noticed when you're going over like the positions for the various like machine learning stuff and the data engineers, is it possible to be a ML expert without pursuing like a PhD or a masterate? And if so, like how does one break into being an machine learning expert? That's my
Oh,
first one. I'm sorry, that was my first question. And the second one was in like the data side of things, how do you measure success like in data? Like for example, in a standard software development team, like they might have a goal of, hey, let's create this app, and the app is created, and like to them that's like, okay, we created this, now we just maintain it. In the data side of like in the data world, like how do you measure like, okay, we've done this, and how do you progress and how do you like see success?
yeah, I love that question. That's such a good question. Those are two really great questions. I'll take that second one first because I think that's also really important, right? Is like many times when we're in our software engineering teams, if we've built an application and we can maintain it and we have this regular cadence of delivery and it feels good to our teams, right? And like really like that's hard. I'm making it sound easy. That's hard, right? Code doesn't exist to live in a silo. That's hard. Getting code out there not traditionally has been very easy, right? But in data teams, we're constantly looking at the performance of our models, right? That's like the life and blood of our solutions. That's how we know that we're doing things right. If I were to build a machine learning model that was going to predict like the prices of the stock market in the next 2 years, right? Put in the stock code, get back out like the predictions for X date, right? If I were to build that and it was inaccurate, think about the impacts that would have, right? And so it's really important that we look at accuracy, precision and accuracy. And we look at it from the perspective of like, what data did we train it with? Like, how is our model learning the indicators of the stock market, right? Because it has to understand that domain, right, to be able to understand like, okay, if this happens in, if this, news breaking thing happens, what happens, like that's going to impact the prediction at the end of the day. So I shared that precision, accuracy, performance curve, right? That's basically what we use. And that's what people will use in research papers when they share their findings, when they talk about it, because at the end of the day, we want to look at fairness, precision, accuracy in terms of machine learning. All right, so for your second question, is it possible for someone to be a machine learning expert, be an ML researcher without a machine learning degree or background? The answer is yes, you can, but it can be very, very challenging. A lot of the research that's being done now is about making machine learning viable for particular use cases. So I mentioned earlier that like before 2010, deep learning was not was like ignored by the scientific community. They said, we're not using deep learning because that doesn't work as well as a decision tree or a random classifier that we can build. And they were like, forget it, like, forget it. Why should we build this model, this complicated deep learning neural network with, you know, all of this design and time spent if it doesn't work well? And it wasn't until there was this competition that they had released in the community and said, like, hey, ML researchers, solve this problem about image classification and identity. So there was this thing called ImageNet that they had released, and it was like a data set full of images that you had to be able to, you had to use a machine learning model to be able to classify it. So they give you a picture of dog, you know, this model would need to know, oh, there's a dog in here, blah, 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 right? And do it with a certain level of accuracy. Again, back to accuracy, right? But, you know, it wasn't until people were like really experimental and wanted to try certain things that they were able to realize, like, oh, deep learning is viable. And all we had to do was just change one way that we were processing the data in the layers. And it got really, it's scientific, right? You have to think about like having a mathematical background, statistics, physics background is really helpful. So I'm just saying that, you know, a lot of times our backgrounds will help us, certain backgrounds will help us get to, you know, that kind of place sooner than others. It's really challenging just because there's been so much work that's been done that unless you have like a good community of, you know, other ML researchers supporting you, it can be really hard to figure out, well, where do I even start and how can I even begin to, you know, push the envelope in what we know about the industry today. You know, I always like to think like people who have the academic background and who are really interested in it, they can do really amazing things. So I always tend to shy away from like needing a master's degree or a PhD to be able to talk about machine learning, but it is really, really challenging to be able to say certain things about a machine learning model or machine learning design without that background. So that's kind of a long-winded answer of like, I think it's challenging, but
Awesome.
there are
Thank you
ways.
so much. You answered both of them. Thank you.
Yeah. Awesome. If anyone else has any questions, feel free to ping me. Like, I want to have these conversations because I think it's so, so important for us to begin to even learn more about this space. And, you know, from the perspective of the data team, like this is how we build cool and usable data solutions, fully integrated. And that's really the goal at the end of the day. So thanks, everyone.
Thanks, Tiffany. That was great.